The universe is supposed to be predictable. Cold physics, clean equations, cause, effect, and the comfort of consistency. And yet, the more we measure it, the more it starts to feel like it is leaning into strangeness, like it is quietly changing the rules while we are still learning the old ones. What if the universe is getting weirder? Not in a flashy way, not in a sci-fi twist, but in the gentle, unnerving way of a familiar room that looks normal until you notice the clock is ticking slightly off beat. If you like calm, sleepy journeys like this, you can subscribe, and we'll drift together again on another night. Now settle in, let your shoulders drop, and let's follow the weirdness slowly, from the largest scales to the smallest, and back again. We begin somewhere simple, somewhere your mind can rest. Imagine you are outside at night. The air is cool, the world is quiet. Above you, the sky looks steady, like it has always looked. A scattered field of stars, a soft band of the Milky Way. A few pinpricks of light that you know are planets, even if they look like stars tonight. From down here, nothing about the universe seems urgent. It seems settled. It seems finished. But out there, beyond what the eye can do, the universe is in motion. Not like a car passing by, but like a tide so large you only notice it by watching for a long time. And we have been watching long enough now that some of our clean expectations start to wobble. To understand why, we first need to hold one comforting idea in our hands. Science does not feel weird because it is sloppy. It feels weird because it is honest. It begins with a model, a map. Then it builds better instruments. Then it compares the map to the territory. And sometimes the territory quietly refuses to match. That mismatch is not a failure. It is the beginning of a deeper truth. So tonight, we treat weird as a signal. Not a punchline, not a panic. A signal that reality is larger than our current story. A gentle companion joins us, like a calm presence at the edge of a dim room. Archivist. When you say the universe is getting weirder, do you mean it is changing, or do you mean we are noticing more? That question is the doorway, because the universe might not be changing at all. It might be steady, and the weirdness might be what happens when our measurements become precise enough to reveal what was always there. Or, in a subtler sense, the universe might be changing in ways that are normal for it, even if they feel strange to us. Either way, the experience is the same. As we look deeper and measure finer, the universe becomes less like a simple clock and more like a living puzzle. We'll plant a few promises early and return to them later, like familiar stars you can always find again. First, we keep returning to a single ancient photon, because every cosmic fact that reaches us arrives as light, stretched and thinned by time. Second, we keep returning to a quiet phrase, simple enough to carry into sleep. The map is not the territory. Third, we keep returning to a horizon, not the edge of space, but the edge of explanation, the place where our confidence fades and the unknown begins. Now we begin the long journey, and we begin with the biggest weirdness of all, because it changes the shape of everything that follows. The universe expands. That idea by itself is already strange, because it means space is not a fixed stage. Space is part of the story. Distances grow, the fabric stretches, galaxies drift apart, not because they are all flying through space like shrapnel, but because space itself changes between them. If you picture a raisin loaf rising in the oven, the raisins move apart as the dough expands. The raisins are galaxies. The dough is space. It is a gentle image, almost cozy. But then we notice something that makes the room feel colder. The expansion is not slowing down the way many people once expected. The expansion appears to be accelerating. Not everywhere, in every local region, because gravity still binds galaxies in clusters. But on the largest scales, the overall expansion seems to speed up over time. This is where the universe first begins to feel like it is getting weirder. Because in everyday life, things slow down unless something pushes them. A rolling ball slows. A swinging pendulum settles. Even a fireworks spark fades. So what is pushing the universe? We call it dark energy. Not because it is a shadowy substance in a container, but because it is a name for whatever is causing the accelerated expansion. Whatever is making the universe behave as if it has a kind of outward pressure. That name is honest. It is a label for a mystery. And this mystery is not small. It is not a detail. It is the dominant behavior of the universe's future. The more time passes, the more the universe becomes a story of separation. Galaxies beyond our local region drift farther away. Their light stretches. Their messages arrive more slowly. The cosmos becomes more isolated. And right away, we feel the first quiet micro-hook. If the universe keeps accelerating, what does that do to what we can ever know? Archivist, does acceleration create a limit? Yes, a horizon. Not a wall you can touch, but a boundary of information. If expansion behaves a certain way, there are regions so distant that signals from them will never reach us, no matter how long we wait. Their light is not too weak. It is simply outpaced by the growth of space between us. So the universe becomes weird, in an emotional way. It becomes a place with permanent secrets. And this brings us to our horizon of explanation, the first one tonight. The universe does not merely contain mysteries, it can enforce them. Now, hold that thought, because we will return to it at the end, and it will feel different then. For now, we stay with dark energy and ask a gentle question. Is dark energy constant? One of the simplest possibilities is that it is a property of space itself, like a constant energy density in the vacuum. If that is true, then as the universe expands and there is more space, there is more of this vacuum energy, and it pushes more strongly in total, making acceleration inevitable. But there are other possibilities. Dark energy might change over time. It might be dynamic. It might be a field. It might be something we have not framed correctly yet. And here is where the weirdness grows. Because when we try to match different kinds of measurements, different ways of measuring expansion, we sometimes get answers that do not perfectly agree. It is as if we measure the universe's heartbeat in two different ways. And one method says the pulse is slightly faster than the other. That tension has a name in modern cosmology. And even if you do not memorize it, the feeling matters. The universe looks like it might be disagreeing with itself. Now, we slow down and make this feel like a story, not a textbook. Imagine you are an archivist in a vast library, and you find two copies of the same ancient record. One is written in careful ink, one is carved into stone. They should say the same thing, but the numbers do not match perfectly. You do not immediately declare that history is broken. You check your reading. You check your tools. You look for smudges, cracks, missing lines. But you also consider the quiet possibility that your understanding of the record is incomplete. That is how cosmology feels right now in certain places. The map does not fully match the territory. The map is not the territory. Archivist. So the universe might be weirder, because our best model is under strain. Yes, and strain is where refinement happens. Now let's bring in our ancient photon for the first time, so the story stays grounded. A photon leaves a distant galaxy. It travels across an expanding universe. While it travels, space stretches its wavelength, like pulling a spring longer. The photon arrives redder than when it left. It arrives as a clue. Most of what we know about the universe comes from collecting vast numbers of those clues, then building a model that makes them fit together. So when clues from different methods do not fit perfectly, it is like the photon is whispering, "Your story is close, but not complete." Now, we glide from dark energy to another cosmic oddity that feels less like a thing and more like a missing thing: dark matter. When astronomers measure how fast galaxies spin and how galaxies move in clusters, the visible matter is not enough to hold them together the way they appear to be held. If you do the gravitational accounting using only stars, gas, and dust, the numbers do not work. The motions suggest there is more mass than we can see. So we propose dark matter. Matter that does not emit light, that does not interact strongly with electromagnetism, but still has gravity. Again, the name is honest. It is a label for an unknown. Dark energy and dark matter together make up most of the universe's content in our current model. Ordinary matter, the stuff of planets and skin and oceans, is only a small fraction. That alone is weird. It is like discovering that almost everything in your home is made of a substance you cannot detect directly, and you only notice it because furniture stays in place. And then it gets weirder, because for decades, we search for dark matter particles directly. We design detectors in deep mines. We look for subtle collisions. We look for signals in the sky. And so far, the story remains unresolved. The universe behaves as if dark matter exists, but the particle remains elusive. So the weirdness becomes a quiet question. Is dark matter a new kind of matter? Or is it gravity behaving differently on large scales? Or is it something even stranger? The map is not the territory. Archivist. You are building a picture where most of the universe is made of unknowns. Yes, and that is already enough to make the universe feel like it is getting weirder. But tonight's title says getting weirder, not being weird. So we ask, why now? Why does it feel like weirdness is increasing? Because our instruments are entering a precision era. We are measuring the universe with enough detail that small cracks become visible. In earlier centuries, our picture was blurry enough that the model felt smooth. Now we see the texture. And texture always looks strange at first. Now we take a soft step into that precision era, and we keep it calm. We map the afterglow of the early universe, the cosmic microwave background, a faint radiation that fills the sky. It is like a baby picture of the universe, a snapshot from a time when the cosmos becomes transparent to light. When we examine that snapshot, we see tiny variations, small temperature differences across the sky. These are the seeds of later structure, the early ripples that will become galaxies. Most of those patterns fit our standard story remarkably well. But here and there are features and anomalies that people debate. Patterns that look odd, alignments that might be statistical flukes, or might be hints of deeper structure. If you are sleepy, you do not need to remember the names of those anomalies. You only need the feeling. Even the baby picture looks slightly mischievous. And the debate itself is part of the weirdness. Because science is now sensitive enough that we argue over subtle patterns in the oldest light we can see. We are reading the universe at the edge of precision, where the difference between random and meaningful becomes a fine, trembling line. That is the horizon of explanation again. Now, let's drift away from the largest scales for a moment and look at something that is weird in a more intimate, physical way. Quantum reality. If the cosmos feels like a grand machine, quantum mechanics is the part that whispers, the machine is not built the way you think. On the smallest scales, particles behave like waves. Outcomes are probabilistic. You do not get one definite path until you measure. Even the idea of a particle being here becomes a statement about likelihood. This is not a small detail. This is the foundation of modern physics. And it is weird in a very specific way. It is weird because it does not behave like our everyday intuition, which evolved for throwing rocks and catching food, not for understanding electrons. Quantum theory works extremely well. It predicts experimental results with astonishing accuracy. But understanding what it means is still a philosophical ache. Is the randomness fundamental, or a sign of missing variables? Do outcomes split into many branches? Does reality collapse when observed? Is the wave function a real thing, or just a mathematical tool? No matter which interpretation you prefer, the universe feels stranger when you think about it. And it gets stranger still when you notice how quantum weirdness and cosmic weirdness might be connected. Because the vacuum, the emptiness of space, is not empty in quantum theory. It seethes with fluctuations, virtual particles appearing and disappearing, a restless background. So when we talk about dark energy as vacuum energy, we are linking the largest behavior of the universe to the smallest weirdness of quantum reality. And when we try to calculate the vacuum energy from quantum field theory, we run into a gap so enormous that it feels like the universe is laughing quietly. The map is not the territory. You are saying our two best theories, quantum physics and gravity, do not fit smoothly together. Yes. And that mismatch is one of the deepest sources of modern weirdness. Gravity describes the large-scale shape of space-time. Quantum theory describes the small-scale behavior of matter and fields. Each is powerful, each is tested, but together they do not form a single, seamless story. So the universe feels like it is getting weirder because we are pressing into the seam where our theories meet, and the stitching shows. Now, we move into a new movement, and we keep the story flowing by asking a question that naturally follows. If our theories do not fully fit, where do we see the tension most sharply? Black holes. Black holes are places where gravity becomes extreme. They are not simply heavy objects. They are regions where space-time curves so strongly that there is a boundary an event horizon beyond which signals cannot return. They are quiet from the outside, and that quietness is part of their strange beauty. Matter falls in, light bends. The horizon forms a one-way surface. If you drop a message into a black hole, it does not come back. And then, the universe gets weirder. Because quantum theory suggests that black holes are not perfectly black. They can emit radiation over time, slowly evaporating. This radiation seems thermal like heat, and it carries little information about what fell in. So we face a puzzle. If a black hole evaporates, what happens to the information about what it swallowed? In quantum physics, information is not supposed to be destroyed, but the naive picture of black hole evaporation seems to erase it. This tension is called the black hole information problem, and it is not just a technical curiosity. It forces us to question what we mean by information, by space, by time, by the reality of the horizon itself. If you want a single place where the universe feels like it is hiding its true rules, black holes are a strong candidate. Archivist. So the universe is getting weirder because we find places where our rules conflict. Yes, and black holes are the loudest, quiet places we know. Now, let's soften for a moment because this is a sleepy journey. Imagine a black hole, not as a monster, but as a calm absence, a dark pond in space-time. The pond has a surface you cannot cross back through. You can circle it. You can watch light curve around it. You can feel its gravity at a distance. The pond does not chase you. It simply is. And then you realize something. The event horizon is not a physical membrane. It is a boundary of information. It is a horizon in the same sense as our cosmic horizons. It is the universe using geometry to define what can be known. So our repeating promise begins to weave itself into everything. The edge is not always a location. It is often a boundary of information. And this makes the universe feel weirder, because it suggests that information is not a side note. It is part of the structure of reality. The map is not the territory. Now we ask a new question, one that adds a quiet layer of unease. If the universe has horizons that hide information, what else might be hidden simply because we sit in one particular place, at one particular time, with one particular set of senses? This is where observational bias enters, and it is not just a scientific technicality. It is a philosophical shadow. We see the universe from inside it. We are not outside looking in. We are participants, embedded observers. We see light that has had time to reach us. We see regions not beyond our horizon. We see history, not now, everywhere. We see the universe through the filter of our location. So the universe can feel like it is getting weirder because we slowly become aware that our view is not complete. This is not a flaw. It is the truth of being inside anything large. Now, let's keep moving, and we do it with a gentle micro hook. If we are embedded observers, could the universe's weirdness be partly about us? That starts to sound like the universe cares. It does not need to care, but our presence can still matter in a subtle way. In physics, the act of measurement is not always passive. In quantum mechanics, measurement plays a special role. In cosmology, selection effects play a special role. Even in biology, survival plays a special role in what kinds of observers exist to ask questions. So the universe can feel like it is getting weirder because we discover that we cannot fully separate the story of the cosmos from the fact that we are here to tell it. Now, we take a careful step into a concept that can easily become too abstract, so we keep it gentle. There are questions about why the constants of nature have the values they do. why the electron has its mass, why the strength of forces allow atoms to exist, why the universe expands in the way it does. Some people interpret this as pure coincidence. Some interpret it as evidence that many universes exist with different constants, and we live in one of the rare ones that allows life. Some interpret it as a sign we do not yet understand deeper principles that set these values. Again, you do not need to pick a side tonight. You only need to feel the weirdness. The universe seems balanced on certain edges, and we do not yet know if that balance is a clue or a mirage. The horizon of explanation appears again, soft and inevitable. Now we shift to something that feels weird in a different way because it happens closer to home, within our own galaxy. The universe sends out bursts and flashes, transient events that light up and vanish, exploding stars, merging neutron stars, gamma ray bursts, fast radio bursts. Some of these are well understood, some are still mysterious. And the mystery is not only the event itself, but the fact that the universe is full of sudden, extreme behavior, like a calm sea that occasionally produces towering waves. It is easy to think of the cosmos as serene, but it is also violent and dynamic. The weirdness is not only in the equations, it is in the temperament. The map is not the territory. Now we let the story return to the theme of getting weirder, not by listing phenomena, but by describing the feeling of scientific time. There is a pattern in the history of science. We begin with a simple picture. Then we build better tools. Then the picture gains detail. Then the detail looks like noise. Then we realize the noise is structure. Think of the sky. For ancient observers, the stars look fixed. Then we notice planets wander. Weirdness increases. Then we build a model. Then it becomes predictable again. Then we build telescopes and discover galaxies. Weirdness increases. Then we build cosmology and it becomes coherent again. Then we build even better instruments and discover dark matter and dark energy. Weirdness increases again. So the universe might not be getting weirder in an absolute sense. Our relationship with it is getting deeper. And deeper often looks strange before it looks simple. But we should not comfort ourselves too quickly, because some weirdness is not just more detail. Some weirdness is contradictions. And contradictions do not always resolve into something cozy. So we take a moment and return to one of the most famous modern contradictions, the one that makes even careful people sit up a little straighter. Different methods of measuring the universe's expansion rate sometimes disagree beyond what seems likely from simple error bars. This might be a sign of hidden systematic errors, or it might be a sign that our model, though powerful, is incomplete. If it is incomplete, then the weirdness is not temporary. It is a doorway into new physics. Archivist. If new physics exists, what could it be? We do not know. But we can imagine categories. Maybe dark energy changes over time. Maybe it is not constant. Maybe gravity behaves slightly differently over cosmic distances. Maybe there are additional kinds of radiation or particles in the early universe that alter expansion. Maybe our assumptions about the early universe's contents need adjustment. Or maybe the disagreement is a mirage created by subtle biases in measurements, and it will resolve as data improves. Either way, the experience is the same for now. We live in a universe that is close to understood, but not fully settled. That is a strange place to be. Now, we take another gentle breath, because it is easy to become overwhelmed by cosmic weirdness if we hold it all at once. So we do what sleepy stories do. We return to a single thread, a single photon. Imagine that ancient photon again. It leaves a star. It travels through a galaxy. It passes dust. It escapes into intergalactic space. It travels for billions of years. It stretches. It cools. Then, it arrives in a telescope, in a detector, as a tiny event. Everything we know about the universe is built from countless events like that, gathered and interpreted. So, in a sense, the universe is not a set of objects. It is a conversation carried by light. And a conversation can become weirder when you realize you have been missing part of the language. The map is not the territory. Now, let's step into a new movement that feels like a turning point. Sometimes the universe feels weirder, not because it contradicts itself, but because it repeats patterns across scales in a way that feels eerie. Spirals appear in galaxies and hurricanes. Waves appear in oceans and in quantum fields. Networks appear in neurons and in cosmic structure. These are not necessarily mystical connections. They can arise from similar mathematics, similar instabilities, similar flows. But the repetition still feels like the universe has a kind of aesthetic. And when you start to notice that aesthetic, you begin to suspect that the universe might be simpler than it looks, but in a way we have not yet captured. Which brings us to a question that sounds simple and is not. Is the universe fundamentally weird? Or is it fundamentally simple, and our minds are just not tuned to its simplicity? Archivist. Maybe weirdness is the feeling of being close to a new simplicity. That is a beautiful thought, and it might be true. Many times in science, strange mess becomes clean once the right framework appears. But we cannot assume it will always happen. Reality does not owe us elegance. It only owes us itself. Now we move from cosmic aesthetics to cosmic coincidences, another flavor of weird. There are numbers in cosmology that look oddly comparable in the current era, like the densities of different components being of the same order today, despite evolving differently over time. This can be a coincidence, or it can be a clue, or it can be a selection effect, meaning we find ourselves in a time when such comparisons are visible because we exist as observers who can make them. Again, you do not need to decide, but you can feel the strange tension between chance and meaning. The universe does not speak in words, but it does speak in patterns. Now we drift toward a deeper strangeness, one that is both scientific and poetic. Time. Time feels like the most basic thing. It flows, we age, days pass, seasons turn. But in physics, time is not always a simple river. Relativity tells us time depends on motion and gravity. Clocks tick differently in different gravitational fields. Time and space are interwoven. In cosmology, time becomes even stranger. The universe has an age, it has a history, it has epochs. In a sense, the universe carries its own clock. And when we talk about the edge of the observable universe, we are really talking about the fact that information cannot travel faster than light. So there are regions whose present we cannot know, only their past. So the universe becomes weird in a quiet way. There is no single universal now that covers everything in an absolute sense. The map is not the territory. Archivist. That makes the universe feel like a layered dream. Yes, a layered archive where every direction is a different time slice. Now, we move into the part where weirdness becomes almost physical in your chest. Because if the universe is accelerating, horizons form. And horizons mean loss. Not loss in our lifetime, but loss in principle. There are galaxies whose light we can see now, whose future we may never witness, because their later signals may never reach us. We can read their history, but not their ending. That is strange. That is like watching the first half of a story, knowing you may never see the last pages. So the universe becomes weirder as it ages, not because it turns chaotic, but because it becomes more isolated. This is a kind of cosmic loneliness built into geometry. And it raises a question that whispers rather than shouts. What does the far future universe look like? If expansion continues, accelerating, the far future could become a quiet place where distant galaxies fade away beyond the horizon, leaving local groups bound together, surrounded by darkness. That future is not frightening. It is simply different from the crowded universe we imagine when we look at deep field images today. It is like a city slowly emptying, not because buildings collapse, but because roads stretch until travel becomes impossible. Now we pause, because this is a perfect moment for the archivist to ground us. You keep returning to horizons. Are horizons the reason the universe feels weirder? They are one reason. A horizon is a boundary created by physics, and it tells us that knowledge has limits. That alone can feel weird to a mind that wants completeness. But horizons are only part of the story. The other part is that the universe's biggest unknowns, dark matter and dark energy, dominate its behavior. So we are living inside a universe where the main actors are not yet fully understood. Imagine reading a novel where most of the characters are named unknown, and yet they drive the plot. That is cosmology right now. The map is not the territory. Now we move into a different kind of weirdness, one that feels like it belongs to dream logic, but it is part of real physics. The idea that empty space has energy, and that this energy might shape the fate of the cosmos. The idea that a black hole can be described in terms of information, like a ledger. The idea that a horizon can store information. These ideas point towards something that many physicists suspect, gently, without certainty. That space-time itself might emerge from something deeper, something like information or entanglement, or a more fundamental structure. If that is true, then the weirdness is not a minor correction. It is a shift in what we think reality is made of. Not only matter in space and time, but relationships, correlations, information. Archivist. That would mean the universe is not built like a stage, but like a web. Yes, and webs are weird in a beautiful way. Pull one strand and the tension changes elsewhere. Now, we do not need to commit to that story, but we can feel its shadow. We can feel that our old picture, space as a container and time as a background, may be too simple. The map is not the territory. Now, let's bring in one more movement that ties cosmic weirdness to a sleepy human feeling. When you lie awake at night, the world becomes simpler. The room is dark. The day is gone. Your thoughts slow down, and small questions can feel huge. In that state, the universe's weirdness can feel intimate, because you realize the atoms in your body are made of quantum fields. The warmth in your skin is energy moving. The light that once touched your eyes left a star long ago. The iron in your blood was forged in an ancient explosion. The universe is not out there, it is in you. So when the universe becomes weirder, it is not just an external story. It is a story about the foundation you sit on. Now, we gently ask the question that the title wants us to ask. What if the universe is getting weirder? What if the weirdness is not an error, but a direction? Here is a calm possibility. As the universe ages, the simple parts become less dominant. Stars burn out slowly over time. Matter clumps into structures, black holes grow, expansion accelerates, horizons tighten. The universe becomes less communicative across large distances. In that sense, the universe might become weirder as it ages, because its large-scale behavior becomes more defined by invisible components and information boundaries. It becomes less like a smooth ocean and more like an archipelago of isolated regions. And here is another possibility. The universe is not getting weirder. We are. Our tools become more sensitive. Our measurements become sharper. Our models become more detailed. And the weirdness is the sensation of stepping into deeper layers of reality. Like focusing a microscope and seeing that what looked like a smooth surface is a landscape. Now we come to the most soothing interpretation, and we offer it gently, not as certainty, but as comfort. Weirdness is not the universe misbehaving, it is the universe revealing itself. The map is not the territory. Now, the story needs a payoff, something that gathers the threads we planted at the beginning and brings them back with weight. We promised a photon. We promised a phrase. We promised a horizon. So let's return to the photon one last time and let it carry the whole meaning. An ancient photon leaves the early universe, or a distant galaxy, or a star that lives and dies long before Earth has names. That photon travels through expanding space. It passes through gravitational fields that bend it. It passes through regions where dark matter shapes its path. It stretches as the universe expands, shaped by whatever dark energy is. It arrives to us as a whisper. We build an instrument to catch it. We build a theory to interpret it. We build a map. And then the map begins to show oddities, tiny mismatches, strange tensions, unexplained components. That is the moment the universe feels like it is getting weirder. But the photon itself is honest. It never lies. It only carries what it carries. So maybe the weirdness is not out there. Maybe the weirdness is in the gap between our models and the full truth. The map is not the territory. And now the horizon, our last promise. The horizon is the point where our confidence fades, where we stop being able to test, where we start having to infer. The universe is full of horizons, the edge of the observable universe, the event horizon of a black hole, the horizon created by accelerating expansion, the horizon created by our own limited position in space-time. Those horizons are what make the universe feel strange, because they tell us that knowledge is local and reality is larger than any one viewpoint. So what if the universe is getting weirder? Then perhaps it is not a warning. Perhaps it is an invitation to refine the map, an invitation to build new instruments, an invitation to be patient with mystery. Because in every era of science, the universe looks weird right before it looks clearer. If you'd like more gentle, space-themed journeys like this, you can like and subscribe, and we'll meet again in the quiet dark between questions. And somewhere far beyond your sight, an ancient photon crosses a widening ocean of space, drifts toward a horizon it may never reach, and keeps traveling anyway.